Hello everyone, this is Arun from SciNote's Customer Success Team. In this video, I'm thrilled to introduce a much requested feature, the integration of a powerful molecular biology tool right here in SciNote. But before we dive into the details, let me give you a quick overview of what this tool is all about. We've named it the Sequence Editor in SciNote, and it's essentially an integration of the powerful open vector editor developed by TeslaGen. The Sequence Editor is a comprehensive molecular biology solution that offers key features required for your plasmid mapping and sequence editing work. We integrated this tool into SciNote to add an element of collaboration that will streamline your organization's molecular biology research. Now that you have a glimpse of what's in store, let's dive right into the action. I'll guide you on how the Sequence Editor works in SciNote, showcasing its incredible features and how they can optimize your research. All right, now that we have SciNote open, we're going to navigate straight to a task. In your task, click Insert, select File, and from here, you'll see the option to click on Sequence, which will open the Sequence Editor tool in SciNote. All right, now that we have the tool open, we first need to import a sequence file so that we can open it in the tool. A quick note here. There's two ways to do it. You can click on the import button here or drag and drop a file into the tool. The compatible file types are FASTA files, GenBank files, DNA files, and JSON files. I already have a file handy, so I'm just going to drag and drop it. The first thing you want to do is switch from the read-only mode to the editing mode, which will allow you to make edits to the sequence. And as you can see, we already have a few important features of this sequence highlighted here. We have the name, the size in base pairs, we have the origin of replication, we have a antibiotic resistance gene, and we also have the gene of interest, in this case, GFP. So the left-hand side of the screen has a visual representation of the plasmid map, and you can toggle between the circular map or linear map depending on your preference. And of course, there is also a zoom in, zoom out tool that you can use right here. On the right-hand side, we have a detailed sequence map of the actual sequence where you can see a lot of the same information in a much more granular manner. This tool also allows you to create annotations. For example, let's say you want to annotate the start and stop codons for the gene of interest, in this case, GFP. So first we have to locate the gene of interest. So when I click on the gene of interest in the circular plasmid map, it will highlight the corresponding sequence in the sequence map. Now I know my start codon is at the beginning, so I just click and highlight the 3 base pairs, right click, go to create, and say new feature. I can give this a name, I'll just call it start codon. And for the feature type, there is actually a type for start. So we'll select that and save this. And then if I scroll down, we find the stop codon here, TAA. So I can highlight that. Same process. All right, so that's just a quick example of how you can annotate any areas of interest in your sequence. Now let's say, for example, we want to use 2 specific restriction enzymes for cloning. In this case, I'll go with BCOK1 and EchoR1. First, we need to ensure that the amplified sequence has these restriction sequences outside of the coding region. So in this case, this is our gene of interest that we're looking to amplify. So on the toolbar here, there's an option to view the cut sites or hide the cut sites. And if I expand this, there's an option to filter to a specific enzyme. So I'm going to search for BCOK1 and also echo R1. And now we can see that both the restriction sequences are outside of the coding region for this gene. Next, let's take a quick look at the primer design feature. First, we click on Edit, followed by Create, and then New Primer. So to create the new primer, you have to select the base pairs directly on the sequence map. So I'm going to select a primer of 20 base pairs that overlap with the start codon here that we've annotated earlier. And I'm just going to call this forward, or the forward primer. And then I'm going to scroll down to the bottom and do the same thing. The other option is also to select the region where you want your primer, right click, go to Create, and select New Primer. In this case, we have the negative strand, and I'm just going to call this reverse. Now that we've created the forward primer and reverse primer, let's say we want to add a restriction site for echo R1 at the start of the primer. So in this case, first I would need to know the actual sequence for echo R1. So for that, I can select Properties, go to Cut Sites, open echo R1, and if you hover over here, there's an option to copy the sequence, jump back to the sequence map, and I'm going to insert this somewhere in the middle of my primer here. So to insert it, just Control V, and there you go. We have the echo R1 restriction site inserted into our forward primer. And if you wanted to add a specific cut site or restriction site for the reverse primer, you would do the same thing. You would copy the sequence for the cut site and paste it or insert it into your reverse primer. Now that we have the primers, let's simulate the PCR reaction. To do this, click on Tools, select Simulate PCR. Next, we have to select the forward primer and reverse primer. In this case, we only have one of each, the ones we just recently created, labeled forward and reverse. But if you had additional primers created, you could simulate the PCR using different combinations or different primers. And once you select the forward and reverse primer, you will have the PCR product output shown here. And of course, you can zoom in or out using the slider here. You can also toggle the view between circular, linear, or the actual sequence map. And if you wanted to, you can download this file as a GenBank, FASTA file, or JSON, and open it back up in the sequence editor in SciNote. A quick note here, if you did download this file and open it, you will see the new cut site that we added for echo R1 for the forward primer. Lastly, let's take a look at simulating a restriction digest. For this, we go to Tools, select Simulate Digestion. And then we have to select the enzymes. We can filter for specific enzymes by searching for them. In this case, let's look for a different enzyme here. We'll go with BSPT0, T1071. And it looks like there are 3 cut sites for this particular enzyme, and we can see the resulting fragments here. If you hover over a specific fragment, it will tell you the size of each fragment. And if you clicked on a fragment, it will highlight the corresponding portion in the sequence map. And if you switched to the circular map, it will highlight it on there as well. If you wanted to copy this image here, there is a copy option on the top right. You click on that, it will copy this image for you to paste elsewhere. Once you're done working on the sequence file, you can click Save on the top left. And if needed, you can export this modified sequence file as a GenBank, FASTA, or JSON file to share outside of SciNote. To do this, you can click on the Export option here, select GenBank, FASTA, or JSON, and SciNote will let you download a file in that format. Otherwise, you can click Save and Close in the top right, and all of your work will be saved right here within this task in SciNote. Any of your team members that have access to this task can open the file, see what you've done, and continue working on the sequence as needed. And there you have it, a brief walkthrough of the sequence editor in SciNote. With this integrated tool, collaboration becomes not just easier, but much more efficient. Multiple users can access and work on projects seamlessly, breaking down any barriers in your molecular biology research. If you have any questions or need additional information, don't hesitate to reach out. Your dedicated customer success manager is just a message away, or you can always drop us an email at premiumsupport@scinote.net. We're here to support you every step of the way. Thank you for joining me today. We're excited to see how the sequence editor transforms your research within SciNote. Until next time, happy SciNoting.